this is the first question. What does not belong to levels of IP addressing, right? Levels of addressing. So when it comes to addressing, there are different situations that we need addresses. For an example, when we uh, store data inside the computer itself need addresses to send data to relevant locations. So that kind of things we call specific addressing, right? This first answer is shows specific address. That specific address means somewhat like that. That means within the computer, we need addresses to store data, right? And there are something called physical addresses. I think you have remember when we were discussing about NIC, network interface cards. I told you that there is something called MAC address, which is given by the manufacturer of that network interface card, and that MAC address is unique to each network interface card. So that is called as physical address, and the logical address is what we call as IP address. We can assign an IP address to computer, and that is called as logical address. And here, this is the wrong answer. Here it says port address, but the correct answer should be port address, P. This is F, but the correct one is P. So port address is also something is there within your computer when you connect outside the computer. Data are passed through those port, not fort, right? So the wrong answer here is this port address, because the correct answer is P. P-O-R-T, port address. The wrong one is fort, right? So what does not belongs to level of addressing is fort address is not belong to level of addressing, because the levels are specific address level, port address, logical and physical addresses. Those are the 4 levels you have. So this will be the wrong answer. And second question, what are the different versions of IP addresses? When it comes to IP addresses, there are 2 different versions which called as IPv4 and IPv6, right? Remember 4 and 6. This 4 IPv4 contain 32-bit values. I think you know about binary numbers and decimal numbers, right? For an example, if you want to convert number 10 to binary, what you do, you will have to divide it by 2 again and again, so on until you receive 1-0 pattern, right? So when you have 1-0 pattern, we say it is a binary number, and when you have that the usual pattern what we use, that is the decimal pattern, right? So in decimal pattern, we have numbers from 0 to 9, and thereafter again 10 means 1 and 0, 11 means 2 ones, 12 means 1 and 2, like that, right? So there are numbers from 0 to 9 when we have decimal numbers, and when we have binary numbers, we have only zeros and ones. So in IPv4, what you have to remember is IPv4 contain 32 bits, right? So here IPv6, it contains 128 bits. So IPv6 is longer than IPv4, right? So the reason is earlier we had this IPv4 numbers which contain 32-bit patterns, and since there are many devices connected to internet, this address space, I mean the number of addresses you could have was not enough with this IPv4. So therefore, this IPv6 came. When you use IPv6, you can have 128 bits, right? So 128 bit long address will be there, and with that address you can connect more devices than IPv4. So here, what are the different version of IP addresses means for IPv4 and IPv6. And what is the possible number of IP addresses for Internet Protocol version 6? So when you have this kind of a question, that means the possible number of IP addresses, right? If someone asks you what is the possible number of IP addresses, you always have to take 2 to the power the number of bits. So when it comes to IPv4, you have 32 bits. Okay, so here if you use IPv4 addresses, you have 32 bits, right? So number of addresses you can have using IPv4 is 2 to the power 32. But in this question, what I have asked you is what is the possible number of IP addresses for Internet Protocol version 6? That means IPv6. So IPv6 has 128 bits. So the number of IP addresses you can have is 2 to the power 128, right? So when it comes to IPv4, we have 32 bits, and therefore the total number of IP addresses you can generate using IPv4 is 2 to the power 32 number of IP addresses. And since you have 128 bits for IPv6, if you use IPv6, you can generate 2 to the power 128 number of IP addresses, right? So that is the idea behind that. Okay, and here you have classes, IP address classes. This is given in your LMS note as well. There are different classes named as class A IP addresses, class B IP addresses, class C IP addresses, as well as class D IP addresses, right? So there are certain patterns that an IP address start. A address start with specific pattern, B address start with specific pattern, like that, right? So when it comes to D address, the pattern it start is this, right? 3 zeros are there, and then 3 ones are there, and the final bit pattern is 0. So you will have to remember that. I'll show you that from LMS note as well. Wait a minute. Here I think you can see this. Here if you see class A addresses, the pattern you have is 0, and then a bit pattern is there, right? After 0, there can be ones or zeros or mix of ones and zeros, right? And class B addresses usually start with 1 and then 0, right? And class C address again start with 110, and class D addresses start with 111 and 0, like that. So you will have to remember all these patterns for the examination. If you feel it's difficult to remember, just start with 0. First 0, and then 1 and 0, then 2 ones and 0, and 3 ones and 0, right? For class A, no ones but 0, and class B, 1 ones and 0, and class C, 2 ones and 0, and class D, 3 ones and 0. So that is the way how you have to remember. If you do not remember, you cannot think and decide what it should be. Just remember that is the pattern, right? So by looking at the pattern only, we can understand that this belongs to class A or class B or class C or D, right? And there are classes called class E as well. Okay. And this one, this is also address. This is an example IP address. You may have not seen this kind of an address. You usually see 192.162.1.1.0 like that. Those kind of IP addresses are the only addresses you have seen, right? Maybe. So this is a special kind of IP address which is called as broadcast address, right? So in broadcast address, what we do is we can broadcast a message, right? So here 255 means 8 ones, right? And again here also 255 means 8 ones. Again 8 ones and again 8 ones. I'll show you that using whiteboard. Right? So if I take this example, assume you have an IP address. So IP address is something like this. You have 4 different sections, right? Here you have, I told you, if we consider IPv4, IPv6 is, the configuration of IPv6 is little bit difficult and different. So we usually talk about this IPv4 when it comes to this subject, right? So I'm not going to go into detail because for this subject you don't have to learn all the details, right? So don't worry, that's why I'm not going to go into details. Just think an IP address consists of 4 different parts. Here you have 8 bits. Right, here also you have 8 bits, here 8 bits, here also 8 bits, right? So this 8 bit can be 1 0 1 1 1. How many now? 1 2 3 4 5 6 7 8. This kind of a pattern. And here also you can have another pattern, 1 1 1 1. 8 bit should be there, 1 2 3 4 5 6 7. Let's say something like that. So here also you have that kind of patterns. First 8 bits, second 8 bits, this one 8 bits, and the last section also you have 8 bits. So all together we have how many bits? We have 32. How it become 32? 4 8s, right? 8 into 4 means 32. So altogether in IPv4 address you have 32 bits. So and it is divided into 4 sections. And when we represent IP address in your computer, right? Because when you want to access internet or when you want to connect to internet, you usually have to put an IP address, or else automatically that service will allocate an IP address to your computer. Otherwise, you cannot access internet or else the other network, right? So what will happen is when it is given in your computer, we usually convert this decimal value into this binary value into decimal value. Right, so I'll quickly calculate this to decimal. I'm not calculating using that manual method. What I'm going to do is I just use the calculator. 1 0 1 1 1 0 0 1. Okay, so the decimal value of this is 185, and then you have to put dot in between to denote a separate section, and second value is again, let me check the second value as well. 0 0 1 1 1 1 1 and 0. So that is given as 62. Right? So I have taken the exact value. This value, the decimal value of this binary value is 62. Like that. Here also you will have a decimal value, and here also you have decimal value. So this value can go from 0 up to 255. The maximum value which can come to this place will be 255. The minimum value you can have on this place is 0, because when you have all zeros, that means when you have 8 zeros, that will become 0. When you have 8 ones, that will become 255. Right? Just think that you have IPv4, and in IPv4 you have 32 number of bits, and then that 32 is divided into 4 sections. Each section contains 8 bits, and when we represent it inside the computer, it is represented using decimal number, and you can write the decimal number, and in between you have dots. Right? So for this notation, we call this is dotted decimal notation. Right? This is dotted decimal notation. This notation is called dotted decimal notation because you have decimals values as well as in between you have dots. Dotted decimal value notation is given like this. And the previous pattern we call, that is the binary notation. When you represent IP address using binary numbers, we say it is binary notation. When you represent an IP address using decimal notation, we say it is dotted decimal notation. So I'm going back to the question now. Now I think you understood what I mentioned as this. So here we have dotted decimal notation. You see that we have 4 sections here. Each section contains 255 numbers. Each section contains this value, which is mentioned as 255. This is the maximum value we can have in this place. So all 4 sections contain maximum value, right? So therefore we say this is broadcast address. So when it is a broadcast address, all the values become full. That means 255 can you 7 ones. 255 means 7 ones. So here first location you have 7 ones, 8 ones, and then second location also you have 8 ones, 8 ones and 8 ones. Right? All 32 bits have filled with ones. So in this kind of address, we call it is broadcast address. This address is used to send messages in broadcast pattern. So message will be broadcasted to all the devices connected to that network, right? And this is a loopback address. So this is usually used to initiate the connection with the internet, with the network when you are connecting to a network. So this is address which is called as loopback address. So remember these two. Broadcast address look like this. All the bit values are filled, and here you have 127.0.0.0, right? Remember this as the loopback address. And next question, first part of an IP address defines the, right? So and another point is here that we know that computers are connected to a network, right? So when it connected to a network, it is not connected to one specific network. There are many different types of network, because we know internet means network of network. There are many networks. So one particular machine should be able to correctly identify using that particular network as well as that particular device, right? So usually network address, or IP address is divided into two sections. Again, this is a bit easy to do in the classroom rather than doing a Zoom lesson, but I'll try to do my best, right? Because there are many things to discuss regarding this topic, right? Okay, so if we have an IP address usually consists of two parts, right? This part is called as network side, and this part is called as host side. When you have 32 number of bits, right? We cannot directly say where the point we divide this number into two different sections. It could be from here or from here, or any place, depend on the type of the network, right? You don't have to go that much deeper. So just think, when you have an IP address, you know that it is 32-bit long, right? So that is divided into two sections. Just remember that it is divided into two sections, and the two sections are network side and host side. So this network side represent network bits, and host side represent host bits, right? For an example, let's say 192.168. Let's say this side, something like this. So I have IP address, we have four sections, and two sections belong to network side, another two sections belongs to host side, right? So this means 192.168 network, right? So if you increase one bit for this side, what will happen? It will become 192.169, right? And another 192.170, like that. This number can change. So when this number changes, that means these are separate networks, not separate machines, separate networks. So in this 192.168 network can contain many computers, and the second network can contain another set of computers, and this third network can contain another set of computers, right? So you can increase this number up to 255.255, because when you have 255, that means that is the maximum value you can assign to each point. So this number can grow up to 255.255. On the other hand, this side also can go up to 255.255. Here also I'll take another example. If you change this value, I'll write it up there. This can grow 1.2 and 1.3 and 1.4, like that. So this means 192.168 network. This first machine address is 1.1. Second machine address is 1.2. Third machine address is 1.3. Fourth one 1.4, like that. So all these stuff belong to this network. So when it comes to this second network also, you can have many number of hosts. That means host means the computers. Remember that, right? So network means different network. Host means the computers. And if you come to the third network also, you can have many number of hosts. That means another set of computers. For an example, if I draw two computers here, server, assume that this is a server, right? So there can be many computers connected to this, and here again another server, right? Here, So in between you will have a router, let's say router. You know that you use a router to connect different networks together. So here you have one network. This is called network 1. Let's say here you have another network. This may be your network 2, right? So you have 2 networks now. For each of these machines, you need IP addresses. You need IP addresses to this machine, and this machine. You should have to have an IP addresses to this machine, and this machine, right? And here you have 2 separate networks, and when signals come to this place, you should be able to identify this side and this side separately. So to identify these 2 sides, you use network address. This will be your network 1 and this will be network 2, right? So using network address, you can identify the network, and using IP address of the machine, you can identify each computer. For an example, this can be 192.168 network, right? 00. And here this side could be 192.168.00. So this will be the network address. This network is this network is this. Let's say 99, sorry. Should be 9. Now you see we have 2 different addresses. This is 168 network, this is 169 network. And here you have 192.168.11, 12, 1.3, like that. Here also you can have 11, 12, 13, like so on. Right? So what you have to remember is you have 2 different sections in an IP address. One is called network and the other is called host. Network is to understand the network side, and host address is to understand the host or the computer address, right? Okay. Okay, I think now you can answer this question. First part of an IP address defines the network ID, right? So network ID is defined by the first part of an IP address. So the same way, second part of an IP address defines host address, right? So host is the second part, network is the first part. And now another concept, internal and external, right? And so here another term is there, which is known as private addresses and public addresses, right? So what we have is we can have set of private addresses within our own network. And when we want to access internet, we cannot use those addresses which we use within our computer network. For an example, assume that you all have your laboratories, right? So inside your laboratory, you have specific set of IP addresses, but the same address cannot be used when you want to go to internet. You will need another address to be used in internet. So the address you are going to use to access internet is called as public address, and that public address is given by your internet service provider, right? I think you already know about your internet service providers, Dialog, Go, Mobitel, or any provider you have connected to, right? So public addresses are given by those service providers, and private addresses can be defined yourself when you connect your devices into your network. So private addresses are used as internal addresses, not external addresses, right? External means outside your network. Internal means inside your network. So when it internal, it is private. When it external, it is public. So internal means your internal network. External means when you access internet, right? Remember those two. And the next one, public addresses are used within the, you know about local area network and wide area. Local area network is the network which connected within one building, right? And wide area network is the one which you use to access internet as well. So public addresses are used outside your network, right? So public addresses are used within wide area network. Okay, what is NAT, right? Now I have already mentioned that you cannot use your private address when you want to access internet, right? You need a private address to use within your network, and you need public address to access internet, right? So how can you use two addresses at the same time? Right? You can't. So what you have to do is, when you go outside your network, you will have to translate your network address into another form, right? That means within your network, that means internally you have private address and externally you have public. So when you want to access outside, you will have to convert private address into public, right? So that process is called as network address translation, right? And that network address translation could be simply referred as NAT. So NAT means network address translation. So this is the process which is used to convert your private addresses into public addresses and vice versa, right? Uh, right. So I have already answered this question, right? NAT means network address translation means converting private address to public, and vice versa means converting public address to private address, right? That conversion process is called as NAT, and both way that will happen, right? Private to public as well as public to private. So for this question, tick should be used for both these choices, right? Okay, which are true. First one, public addresses are assigned by the service provider. User can change the public address. Private addresses are unique globally, right? So this is wrong. Private addresses are unique globally. If it is unique globally, you should be able to use it outside, right? It cannot be used outside. That means it is not unique outside your network, right? And user can change the public address. No, I told you public addresses are given by your internet service provider, so you can't access that and change, right? And this one, public addresses are assigned by the service provider, of course, yes. And next one again, which are true. Dynamic addresses are changed with time. Dynamic addresses are generated by DHCP server. Dynamic addresses are used by the servers to maintain constant access. Okay, I think when we were discussing first set of questions, I told you, when you want to access internet to any network, you will have to have an IP address. You will have to put the IP address, insert IP address into your computer, or else it will automatically assign that, right? When it is automatically assigned, right, an IP address will be automatically generated and then it is given to you, right? When you are connecting to internet using your mobile devices, that means mobile phones, you usually do not set an IP address, right? But what will happen is your service provider, through your service provider, you will have automatic IP address, which is different from another one, right? When we connect to the same network, when we have 5 devices connected to the same network, all those 5 devices needs different addresses, right? No conflict should be there. So what will happen is, when it is assigned automatically, it will generate a dynamic address. So that is called dynamic address. And if you assign a specific address, that means if you have 5 computers, you will have to use 5 different IP addresses for all 5 computers. If you do so, it will be a static IP address, right? So remember, when it comes to IP addresses, you have 2 different types: dynamic IP and static IP. Static IPs are given by you or me or any person who is manually assign it, right? So dynamic address will be automatically generated. That automatically generating process is happened using a server which is called as DHCP server, right? So this server will generate uh, an automatic IP address for your computers, right? This is not a separate machine, right? I think you all have seen your server computers inside the laboratory. Within that server computers, within that, this works as a separate software component, right? So this software component will automatically generate an IP address, and it is given to the computers attached to that server, right? When you have a laboratory, if you are not going to give different IP addresses to each and every machine, and if you have installed this DHCP server, what this does is, when your computers, that means when the computers inside your laboratory turns on, this server will automatically assign an IP address to that machine, right? So that is called as dynamic address. So both these are true. Dynamic address are changed with time. Dynamic addresses are generated by the DHCP server. This change with time means, if you turn on your laboratory machine today, right, and tomorrow as well, the address you get today will be different with the address you will have tomorrow, right? It will change time to time. But if you have static IP address, it will not change, because you use that IP address to each and every machine. You manually assign it. Therefore, static addresses do not change. But when it comes to dynamic addresses, it will change time to time. When you restart your machine, again, you will have another IP address, right? Okay, a blank is a binary mask used to divide an IP address into subnet, right? Okay, another point is there. Uh, I told you that we can have number of networks, right? And one network could be divided into more networks. I'll stop this and move to that whiteboard again, then it will be clear to you. Okay, here I told you, let's it's a different color. Here we have two separate networks, network 1 and network 2. Here we have 3 computers, and here we have another 3 computers. So if we take these two, we can take this one as a subnetwork and assume that you have another computer here, right? So we can take these two as another network, right? So N1, network 1, subnetwork 1, network 1, subnetwork 2, like that. So this network could be divided into more networks. So this is called as subnetworking, right? You have a network and you divide it into subsections. So you have another set of networks within this big network. So this is called as subnetworking, right? Okay, I'll move back to the question. Okay, so to divide that, you need to mention how you do. The way you mention is you need something called network mask, right? So you say how many bits are used to separate that network. So that is called as network mask. Remember that. If you want to divide a bigger network into subnetwork, it is called subnetworking, and that happens with help of net mask. Net mask. You will have to use network mask. This is also called as network mask. You can use either net mask or network mask, and subnetworks or subnets, right? Okay. Right. And these things just remember, right? Okay, CIDR addressing. This is also kind of addressing scheme. And when you are asked what is this, this is an addressing scheme. Uh, this also use a prefix to represent an IP address. And the purpose of having CIDR is it will reduce the size of routing table, and it will help you to make more IP addresses. This is a way of this is kind of a notation, right? We used to define a certain uh, IP addresses, right? This is a specific way of defining an IP address. So just remember these points. This is an addressing scheme, and it has a network prefix, and it is used for mm, this purpose. That means to reduce the routing table size, and then it will allow you to make more IP addresses. No need to go into detail. If you go into detail, it will be a bit difficult, right? That's why I'm not going to explain that in detail, right? Just remember, since all these things are given in your LMS, just remember for the examination, right? Since you are HNDA DA students, you will not have to learn more than this, right? That will be enough. Okay. We have discussed this one. Blank is a process of dividing a network into subnetwork, right? So if you want to divide one network into small networks, we call that as subnetting or subnetworking. Both terms are used, subnetting or subnetworking. So subnetting is a process of dividing network into subnetworks, or else subnetworking is a process of dividing a network into subnetwork. Right? Those two terms are valid. Okay. A blank is a hardware device that facilitates communication between networks. So in this point, you will have to think of one thing here. It says hardware device, right? And answers are given. IP address. IP address is not a hardware device, right? And two devices are there: default gateway and network interface card. Network interface card, you already know, this is what we plugged into your computer, and or you have a wireless one, right, which is used to connect into a network. And these two are hardware devices, right? So network interface card is used to what we call uh, uh, it is used to connect into uh, any network. So, but the question asks uh, a device which facilitates communication between networks. Between networks means between two separate networks, right? So clearly understand the question. Here it asks about what kind of devices are used to uh, facilitate the communication between networks, right? That means if you want to communicate from one network to another network, what should be there in between? The one which should be there in between is your default gateway. This will usually be your router. So address of the router will be used as your default gateway, right? So remember this name, default gateway is the one which is used to uh, separate two different networks, right? So next question. Again, you will have to fill the blank. A blank is used to identify one or more IP addresses or computers or devices which administrated uh, as a unit, right? Okay. Mm. So here default gateway we already have discussed, and network mask also we have discussed. So domain name, there are set of domain names which can be used as top level domain and second level domain, like that, right? So domain name is used to recognize a recognize a specific set of IP addresses. So when you have a domain name, under that domain name you can have subdomains as well. I think that question was there down below, right? So we'll go into that question later. So for this one, just remember that a domain name is the one which is used to identify one or more IP addresses, right? So it will usually represent a specific unit, right? I'll come into that with the other questions. And again, this is also about domain name system. Domain name system is a hierarchical, decentralized internet system that translate domain names into IP addresses, right? So when you access internet, right, we know that each and every device use an IP address. But if you want to use Google website, and you will go to a specific server, and there are machines and servers, right? They also use IP addresses, but you cannot remember all those IP addresses. What you usually remember is you remember google.com, right? So there you have .com domain name, right? .com domain, and using that domain and the domain name, what you do is you can easily use internet or any other service, right, instead of remembering IP address. So what this domain system does is it will translate domain names into IP addresses, right? So if you have domain name systems, which is simply called as DNS, right? DNS, it is same as domain name system. It will convert your domain name into IP addresses, because machines use IP addresses. Since we can't remember IP addresses of each and every service, what we do is we remember the address of that website, right? We remember the domain name. And here we have discussed that we have a hierarchical system of domains, and we have set of top level domains and subdomains as well. So here if we check this AC, LK, EDU, Gov, out of this LK is a top level domain, EDU is top level domain, Gov is top level domain, but AC is not a top level domain. Top level domains comes at the end. Google.com. If you say google.com, .com is the last part, right? So .com is the top level domain. And if you say google.lk, lk is the last part. So that is also a top level domain. Edu is also like that. Gov also like that, right? But AC, you know that we usually say something like ac.lk. So lk is the last part, AC is the second last. So that second last one is not called as top level domain. Last part is called as top level domains. So this AC usually comes as ac.lk like, right? And here, okay, a blank is a computer server that contains a database of IP addresses and their associated uh, host names. So this is called as a DNS server. So we have already discussed about domain name system and domain name, and now we have come to domain name system, DNS server. So this server is the one which has the database of IP addresses and host name, because we have already said that uh, domain name system converts names into IP addresses, and it should have to have a database to do that. So this is the place where that database is, right? So remember, this DNS server contains a database of addresses associated with the host names. Okay. Um, and this one, the order of this is an address uh, which is called as URL, right? Uniform Resource Locator. This URL have certain sections. So this is the protocol. Protocol is Hypertext Transfer Protocol, which is mentioned as HTTP. Sometimes you will have HTTPS in some websites, right? So that is called as Hypertext Transfer Protocol Secure. And here you have the address of the server. So the server is www.bit.lk, that is the server, right? And port 8080 port, and here you have the path exam, and then what is the file, index.php file, right? So that is what you that is the order of a URL, right? URL. This is called as URL. URL have specific sections. First, it will contain the protocol, and then the server and port, and then path where the file is, and at the end, the name of the file, right? Okay. So domain name system, we have already discussed about domain name system. So domain name system will convert IP addresses into human-friendly names. It is true. It will be fault tolerant, and it will not be maintained by a central register. We have already discussed that it has a DNS server, right? Using that DNS server, that means it is the place where we have that database. Using that database, it will convert IP addresses into friendly names, not using a central register, right? So all those IP addresses should be managed by, I mean, there should be a responsible party to do all this stuff, right? So this is the responsible party, ICANN, right? So this ICANN, this organization is responsible for managing the IP address space and domain names, and this the protocols, port numbers, all those things are defined by these people, right? ICNN. So if you search internet, you will find more detail about this this organization, and this is the one who will control all this stuff when you connect to internet.